I am Grishma from Group 127, working on the project IoT-based voice-enabled home automation system. So coming to the key components, the first thing that we have is a voice-activated module. In this, we have a module called ESP32S3, which is a microcontroller and also has an inbuilt microphone in it. And the second thing is an IoT device control. This essentially means all the smart devices that we use, such as the smart bulbs, smart fans, and ACs, which are used in our project. And then the third one we have is a website. So the website has all the details of the connection, such as if a device is connected or disconnected, or all the log data of the connected devices would be shown on our website. Talking about the communication flow, firstly, we would be taking the voice input from the user, and this is processed locally at the ESP32. And once we find the keyword, a trigger would be sent based on the keyword to the connected IoT device. And we have a channel for this. And once the trigger is sent to the IoT device, it processes it and the action is executed. And we send that if this is executed or if we're facing some error back again to the ESP32, and this data is shown on our website. Coming to the tech stack, for the hardware, we'll be using ESP32S3 as you've seen before in the previous slides. And for the firmware, we're using the Arduino IDE, where all the program would be written that is essential for ESP32's working. And we are also using Edge Impulse for the voice recognition. This is where we give all our data and train accordingly. And for the website development, in the front end, we are using HTML, CSS, JavaScript, and of course, React. And in the back end, we're using Node.js and Express. And for the database, we're using MongoDB to store the user's information and also the log data. The next thing that we'll be going through is the roles. In our website, we have two roles, the admin and the user. The user has the ability to connect and disconnect the IoT devices and also has the access to view the log data of previously connected and currently connected devices. And then we have the admin, which has all the privileges in our website. Then coming to the interfaces, we majorly have three interfaces. The first one being the voice command interface, where it interprets the spoken words and convert this into our keywords that we would be using in our later stages. And then the second one is our website, which is the platform where a user could see what is really happening and what is the underlying things that's going on about the operation. And the talking about the data sets, we are manually giving our data in the Edge Impulse platform where we train and test our data, and we will be getting the inference which would be later given in the Arduino IDE. Then talking about the input and output screens, firstly, the only input that we have is the voice command that the user gives. And this will be our input. And the output would be, there are two types of output. One is the trigger and action that happens at the IoT device end. And the second one is the log data that we would be seeing in the website screen. Coming to the workflow of a project, firstly, we would be taking the voice input from our user. And once we have this voice input, we would be processing this locally. And we would be getting a keyword. And this keyword would be having a specific trigger action. So this trigger action via a communication channel would be sent to the IoT device. And the trigger is executed over there. And once it is executed, we would be getting another message across this communication channel again to the ESP32, and via another channel we would be establishing a connection to the website where all this log data would be stored in our database, and from the backend we'd be retrieving it to the website. So this is the whole process from the input to the output. Talking about the business logic, the first one is command recognition and mapping. There are multiple commands for a single device, such as to turn on, turn off, or increase or decrease the temperature. So each and every command and giving them a specific trigger action would be in our first logic. And the second one being data logging. Each and every action that has happened in the device would be tracked, and this is stored in our database to retrieve in the log data. And this is a second logic which gives the complete history of the previously connected devices and also the currently connected devices. Coming to the source of information, all this information is sourced from various research publications and also documentations from different sites and also from some online communities. Thank you.